Hello, James. Yeah, your audio's off. Doesn't matter.
Good to see you. It's been a while.
Yeah, we might see you at Sesame,
I hope so.
perhaps.
I hope so one of these days, yes.
Yeah. Okay, good.
So the next speaker is Dr. Edward Mitchell. He's head of business development at the European Synchrotron Radiation Facility and driven by commitment to bridge cutting-edge X-ray facilities to industrial applications by managing relationships that generate both significant real-world impact and annual revenue at ESRF. He focuses on engaging industry with state-of-the-art research infrastructure capacities and skills. He is also passionate in supporting the Sesame Light Source and the African Light Source Foundation, advocating for the development of research infrastructure across the world. Um, Please, Dr. Edward, the floor is yours.
Thank you very much. So I was asked to give a little bit of an insight into how we work with industry down at the European Synchrotron, but this reflects really how many of the large-scale research infrastructures, be they synchrotron facilities, neutron facilities, or lasers, how we try to work with industry. As you'll see, there are challenges and there are successes, and it's not a straightforward path. But we have a lot of fun in trying to optimize this and how we do things with industry. Anyway, so I could do about, I think, 40 minutes or so, right? I've probably got too many slides, and I'll work that out as I go, and we'll just see where this goes. So I get to work at the European Synchrotron. I've been here for forever. I came to the ESRF immediately after my finishing my PhD, and the ambition wasn't to stay at the ESRF in France, but that's how it turned out. And I've had an awful lot of fun doing many different things at the synchrotron. Wonderful places to work, and we have a wonderful time every day. I work in Grenoble. This is Grenoble. You can see the mountain, one of the mountain ranges in the background. The synchrotron you can see right up in the corner of the presqu'île between the two rivers in Grenoble. You can see the old town of Grenoble with the red roofs. And then we're out on the Science and Technology campus called Giant, the Grenoble campus for new technologies. And we're part of around 10,000 researchers and engineers who work on that campus. It's a very exciting place to be based. Give a little bit more background on the ESRF. We are in France, so sometimes the very famous Tour de France bike race goes in front of our gates, and then I get to do footage from France TV showing our synchrotron. So this is our synchrotron. You see a little bit more of how it feels in the background. You see the grey dome. That's the Institut Langevin, which is the world's brightest neutron source, and the ESRF, we're the world's basically the brightest synchrotron X-ray source. We are funded in our case, by 19 member states, including Germany, the UK, Italy, France, and many others, and including Russia. Now, at the moment, our relationship with Russia is on pause, is on hold, and we have no links with Russia at this time, although legally they are still a member of the ESRF. We have 10,000 scientists coming to travel or use the ESRF by remote means every year. We have actually about one scientific publication. I can't work that out. I'm a chemist, so I can't do maths. 7 publications per week coming out, no, per day coming out from the ESRF. My word, my brain's not working. And a lot of our research, the last number you can see there, is about 30% of our research is actually with industrial partners in some way. So either that's an industrial partner buying an access or collaborating with an academic with a PhD student, or the results are being used by an industrial. Each of our member states has a different shareholding. The biggest are France and Germany, followed by Italy, the UK, then Russia, and then there are consortia. We also have associates. So associate countries are not the members, but they pay into the ESRF and have access to our facilities as well. So in that mix there, point out we've got South Africa, Israel, and Russia are non-European partners, and we expect there be some others joining perhaps very soon. This is a closer look at the campus we're on. So the ESRF is down in the corner here with the ILL, and then back over here is the giant campus. And this is composed of, skip that, there we go, of different sectors of the campus. So we're the large-scale research infrastructure down at the end. Nearby, we've got ST microelectronics. If you have a phone, a mobile phone, some sort, mobile phone, here's my one, you're going to have a little bit of ST microelectronics is in there somewhere. Then we have the CEA, the CNRS, with basic science, including renewable energies. Together with Minitech, there's some health going on down here. But also on the campus, we have housing, shops, and there's companies as well as the Grenoble Management School. So it's a very broad, compact very broad in the sense of science and what we do, but very compact. It's quite a small campus over here in Grenoble. Don't worry about that. The ESRF has, there are only two international synchrotrons in the world. There's the ESRF and then there's Sesame out in Jordan, which is also international. And at the ESRF, our mission is very much to bring nations together, our 19 member states and beyond, in working jointly together on science and to advance knowledge. We have a full mission to foster the use of X-rays by industry, which is what we're going to talk about in the next 30, 40 minutes or so. And this is really a core part of our mission. Many people often think, well, you've got these academic research infrastructures that have got nothing to do with industry, and it's really not part of the mission. But actually, our stakeholders, the funding bodies who give us 90 million euros a year to operate and run the ESRF, there's an expectation and a demand, in fact, I would dare to say, that we do work with industry in a variety of different ways. Of course, the ESRF, we have core missions, education, training, science excellence, international collaboration, technology and innovation, and industry is embedded in all of these areas. Throughout those, we are working with industry in some way. Today, I'm going to be mostly talking about industry as a user of the ESRF and a little bit of tech transfer. And that use of the ESRF for industry was embedded decades ago in the 1980s when the International Convention of the ESRF was written. And in here it says, recognizing that synchrotron radiation will in the future be of great significance in many different fields and for industrial applications. And I'm delighted on a daily basis that somebody wise, and I don't know who it was, but somebody wise wrote that into our international governance statutes because it really gives the basis that we should and must engage with industry. So yes, the ESRF is very much open, like all of the research infrastructures for industry. And this has evolved over the years. I think it's best to be candid. You go back maybe 20 years, and it was more like we might engage with industry, and then with time, it's well we could because it's probably a good idea, and then it became well, we ought to really engage with industry. We should do that, right? And then the member states, well, actually want to see more of this. You must work with industry. You must develop your relationship with industry. You must be creative and entrepreneurial. And I think now, especially with some of the younger scientists, we very much like and we love working with industry because there's good science. It brings new resources. It brings different ways of working. As I said, brings great science, challenging science that really calls upon what we can do at the ESRF. And I think that's very much part of the life of the ESRF now, is this sort of industrial element of what we're doing. It's one of the pillars. The ESRF will operate 40 different X-ray beamlines. Now, each of those is custom designed, custom built for a different technique. These are 3 examples, BM18 for micro CT, ID30 for structural biology. We'll take a closer look at that later on. ID20 for inelastic X-ray scattering. Now, each of those beamlines has a vastly different dimension of engaging with industry. BM18, CT, has a big engagement with industry. ID30 with structural biology has a huge engagement with industry for drug discovery. ID20 with inelastic X-ray scattering, that's a technique that is not at all widely used by industry at the moment. It's quite slow. It's not standard. It needs a deep understanding of the technique. And because it's slow, it's also expensive because it's using more time of the synchrotron. Whereas structural biology, each sample takes maybe 2, 3, 4 minutes to collect, which means that actually accessing the synchrotron for doing structural biology, as you can see in the video, it's about 80 euros, 100 euros a sample. And basically any company could do that. For micro CT up here, or maybe it's 1,000, maybe it's 2,000, maybe 3,000 to run a CT. That's also very affordable for a wide range of companies, especially given the data that they get out of it. So why do we work with industry? Because that's an important question, and it's a question we're asked a lot here because it's effort to work with industry. It's not like working with academics. It's different. You need to hold their hands. You need to work in different ways, and there's not necessarily a publication coming out of it, which is also something we'll touch upon a little bit later on. But nonetheless, our stakeholders, our funding bodies, want us to work with industry. So there's the impact stories. I'll tell you some stories later on today about the outcomes with industry. And it's the politics of demonstrating the use of our facilities and skills, the intellectual property we have at the ESRF, and valorizing that within the ESRF and for our stakeholders. As I mentioned, it's good science. There's very, very challenging samples coming from industry with real materials, real objects. But also because if industry is very cost sensitive, it makes us think about how we can be efficient. Should we adopt certain standards? Should we be more rigorous? Should we have different access modes? Should we have standard operating procedures? Should we even dare think about things like ISO 9000? Because these are the kinds of things that speak to industry, and sometimes industry is demanding that we think like that. In some ways, one of the most important is actually not everybody can stay at somewhere like the ESRF. Not everybody's going to be a group head or professor in academia. And the career opportunities in industry, and given the networks we have with industry, is also an important opportunity for our staff to be in touch with industry. We recently had an ESRF kind of Science Away Day, and the question was asked, who would like to go and work in industry after you finish your studentship? There was PhD students, and at least half the audience put up their hand saying, yes, we want to go to industry. And that's also quite a change over the last years, with more younger people that are being trained at the ESRF seeking opportunities in industry. So our network with industry is an important angle of perhaps trying to help them find opportunities. Last one, money. Okay, it's an important thing. The ESRF is costs 90 million euros a year. Budgets are constrained at the moment. It's not easy to find money, and so the money that we bring in from selling services and access to industry helps the ESRF. It brings us more money. We can hire more staff. We can buy more and better equipment for the beamline. So the financial side is not insignificant. So how are X-rays used by industry? You go back only a few years, not so long after Röntgen discovered X-rays way back in 1895. X-rays are already being used for innovation and looking inside stuff. And the stuff that was being checked out here, this is just an advertisement from 1928. So that's what, 33 years after their discovery. X-rays here were being used by the US Rubber Company to look inside golf balls. They were using it for quality assurance, but also for marketing. Right? This is it's an advert saying, come and use our golf balls because the center of the golf ball is nice and spherical compared to other golf balls from the competitors that are actually, they're pretty wonky and rubbish. And by doing so, you're going to get your golf score going from 102 down to 91. So they were using it for quality control and advertising. That's not so different to somehow what we do today. This is an inhaler. If you have asthma, you might use one of these. And this is a high-speed X-ray radiography of an inhaler slowed down, but looking at the moment that the drug is released from inside the inhaler, go like that. This is what's happening inside the inhaler. And this is work with Priors from Ireland, and they wanted to understand what was the dynamics behind the drug release moment and what was happening at that time when the drug is released and it flies down the inhaler, because not much of that drug that's artificially colored here in green just for the video is actually getting to the target in the lungs. And they wanted to look at the kind of the powder fluid dynamics to understand what's going on. And the way that you could look inside the inhaler, because you can't look inside it with visible light, is with X-rays. And this was done a long time ago now, in 2018. And now Priors have done a lot more work on these inhalers with us, using both commercial paid-for beam time and academic beam time. And they're actually an engineering company that help the pharmaceutical companies who use the inhalers to design and develop better inhalers. Why does industry come to us? Okay, so there might be more complex experiments like the one you just saw with the inhaler and doing very high-speed radiography to watch what's going on. But they also come for routine measurements. So not experiments, but areas where the synchrotron properties allow many samples to be collected with very high quality data in a short space of time. And we'll show you some examples of that. And these are, I would dare to say, the majority of where we're doing our work with industry at the moment, is these kind of routine measurements or routine experiments. The complex experiments with a sample environment and catalysis, for example, it happens, but it's not the most of the work that we're doing, at least not at the ESRF. So why? With synchrotron X-rays, you can see inside larger objects. And we have a beamline now, BM18, where you can put a 2-meter sized object on there and zoom down and scan parts of it at a very high precision, submicron, or you can scan the whole object at, say, 10 to 100 microns resolution and do it quite fast. And so our X-rays allow us to see inside large, dense objects. But you can also zoom in on a larger object, but a very, very fine resolution, really down to 20 to 10 nanometers on some of our beamlines. A key point is the speed, because we've got so many X-rays available from the synchrotron, we can go faster. To measure many, many samples, as I just said, or because you've got so many X-rays, you can have better statistical measurements in terms of measuring many similar objects. Because maybe you're looking for a defect, and the defect in the battery or the additive manufactured object might only be present in 1 out of 100 objects, but that one is the one you want to look at. And of course, because we've got lots of X-rays in terms of chemical information, we have a very strongly improved detection limit. And all of these things combined together, as well as being able to do real samples under real conditions, are some of the key elements why industry might come and use us. Because you can put a real battery on the beamline, watch it charge, discharge, watch it blow up. You can mimic the conditions of a furnace to understand what's happening with an alloy. This is Peter Lee and team from UCL in the UK who watch 3D printing processes with a laser in real time, again on ID19 using high-speed radiography. This is work with Peter Hutchins from Prism Scientific, who is watching diesel injectors in live mode on the beamline. So this is diesel fuel being spewed out of the injector, and they wanted to see, again, the dynamics of how that was working. And really, when you start seeing these kinds of things working, the only limitation to what we can do on the beamlines is imagination and maybe some level of funding and money. We did a survey with industry just to try to understand, why do they see collaborating with the ESRF? And the clear winner was the advanced synchrotron techniques that are available that allow them to see things that they can't see with traditional techniques. And that was by far and away the key reason for coming to use the ESRF. It's somehow obvious, but it was nice to see that actually sort of responding and coming back with people saying that. This is my desk. It's where I'm sitting at the moment, and it's around here in front of me. Much of the work we do with industry we can't talk about because it is confidential. I'm going to show you a few examples where we're allowed to talk about it. But on my desk, it was relatively clean on that day when I took the photograph. You get a flavor of some of the objects that we look at. So we do work on, for example, food formulation. This is, I don't know what that is. It's like some kind of chocolate yogurt. We've baked bread on the beamlines. We've looked at emulsions for yogurt, for cheese. We look at paper, for example, microprocessors, sorry, for computing, better batteries. We have lifetime and safety issues. We've looked at seeds and crops to understand their structures to make them more adapted to certain environments. Outside tires on cars, we've looked at tires materials to make them more longer lasting. We've looked at manufacturing glasses to make the process more energy efficient. Up in the air, there might have been an aircraft, but looking at stress strain on aircraft materials because you don't want your aircraft to break apart in the air. Catalysts is a big area. Photovoltaics, medical devices you just saw, advanced materials, all sorts of stuff. But you get the idea. With a synchrotron, we can look at a huge range of different materials, which is also part of the challenge in marketing, actually. But we can do a lot of work with many, many different industry areas. So we engage with industry by providing proprietary services. So not like the academic access. Somebody rings us up, gets in touch. We provide a quotation and we give them access as soon as we can. Our record is the day after, which is exceptionally rapid. Normally it's 2 to 3, maybe 4 weeks to provide an access. At the ESRF, we've got about 300 clients across 35 countries around the world. A lot of work with industry is done through mail-in services. And this represents about 75% of the commercial income at the ESRF. We have a lot of technologies. At the moment, we have about 35 technologies, in fact, licensed. Some of those licenses are now dead, but over the history of the ESRF, it's about 35 technologies that have been licensed to companies and then manufacture them and sell them to clients, usually other synchrotrons. And that's also how we share our technologies. We also manufacture and sell our own devices sometimes, and that generates actually quite a large amount of income and also helps share what we've developed in the ESRF, but is not worth doing a technology transfer, if that makes sense. And then we sell that on. We also work with industry through public access. Industry is more than welcome to apply for free beam time, as long as they publish the data and the results. It's a little bit slower, it takes 6 to 9 months to have the access, but industry is very active in this area here, and we're very happy and very pleased to see that. And we are developing our work with industry through collaborations and grants as well. Well, one of the main ways we actually work with industry, which I'm not going to talk about today, is when we buy technology. Now, the ESRF buys in a lot of detectors, high precision mechanics and engineering, and that's also another important way we work with industry. And there's a very large grey space here of co-innovation, which I don't have time to talk about today, but is another huge topic of research infrastructures working with industry. We try to make things simple for industry. We have fixed price per sample mail-in services. So MX, the price is actually now closer to 80 to 90 euros. Small angle X-ray scattering, about 150 euros a sample. We can provide tailored full service work for more complex experiments, say in situ catalysis or something. We try and keep our quotes simple. Our quote is actually only 2 pages with very clear terms and conditions. And all the IPR is the intellectual property rights. They're owned by the client. So there's no debate about it. Inside the BDO, inside the ESRF, we set it up a dedicated commercial team, the Business Development Office. And it's our mission to engage with industry, to generate income, collaborations, and partnerships with industry. And we're lucky that in structural biology, tomography, now topography, and small angle X-ray scattering, we have dedicated support scientists on the beamlines that help us in doing the work with industry. And absolutely critical to providing a very high level quality support, as is the admin team in providing the access, the quotes, and the support to the industrial researchers to have the access, which is part of the service that we provide. In terms of funding, just down here, in terms of income, last year we generated about 4 million euros from providing proprietary services and about 0.5 million euros in terms of tech transfer. We actually have a target annually, which I haven't put here yet, for the income. This is how it breaks down for the commercial income at the ESRF. You can see that the bulk of the income is generated in tomography, topography, and structural biology, which is basically protein crystallography in this case. And between those three techniques, they're generating, well, about 75% of our commercial income. If you go back 10 or 15 years, this pie chart would look much differently, much more different than this, and it would have been about 80% structural biology. And I think that's part of the work we've been doing over the last few years is to diversify the techniques and how we are working with industry. This is how our income looks because the commercial income is actually our only formalized value measure, our only key performance metric for the Business Development Office is how much money have we earned for the ESRF. And this is it through the years. Our member states have demanded that we grow the business by 5% year on year. Down here, we did the ESRF upgrade, so we were shut, which is why the income is modest because we didn't have any X-rays. And then last year, I said we're at about 4.5 million euros income. And this is split between instrumentation and beam time. And this is our target, the grey line down here, as set by the member states. So in 24-25, we've largely outperformed it, which is great. But this also puts strain because the more income we earn, the more beam time and resources we are using for industry. And that becomes a tricky equation for a research infrastructure that is largely academic and where the careers of some staff might rely heavily on publications and not necessarily working with industry. And then that balance between industry, commercial work, academic work, the impact of the facility, the mission of the facility is an important point of debate. And it's important that internally it is clear to everybody what is happening, what the expectations are. And this is that tension because on one side, you have the commercial income. On the other side, you have the output of the ESRF in terms of publication numbers. And the more beam time we take from this side to generate income this side, that has a tension and a balance between those two sides. So our member states, our stakeholders, the taxpayers that pay for the ESRF, they probably want to see both commercial income and the publications. Now, the publications lead to commercial impact longer term as the science in those papers gets transformed into market knowledge and products. This is a shorter turnaround in terms of that impact. So probably we need both. But then there's a strategic decision in the facility as to where that balance is. And that's sometimes not always easy to define and think about where that is. And that depends also on individual facility policies and the nature of the facility about what it is told to do by its stakeholders. Our internal view of the ESRF is very much that we're a unique large-scale instrument. It's state of the art. We can do fantastic, amazing science, and we get great nature papers. Look what we can do, and that's wow, that's gorgeous. But for industry, that can translate, and it's our image in industry for many of the facilities is well, That must mean you're probably pretty expensive, man, right? It's going to be really difficult and tricky to use. Probably means it's going to be risky. And they're really, we think you only do fundamental science, right? So why on earth would industry come to you? Because we're not interested really in any of those things because it's we want impact on the bottom line now. So really, well, these facilities not for me. And industry is making a choice between safe and risky, and industry is often largely safe. So a lot of the work we do is to kind of remodel the brand, the image of the ESRF in the eyes of industry and show our relevance. And very much now we are adapting the ESRF to industry and not adapting industry to the ESRF. We are adapting our procedures, we're adapting our beamlines in some cases, our services to what industry needs, and not just expecting to get industry to go, wow, that's really good, I'm going to come and use you. We need to, there's a two-way path, and that's important. I think that's a change in how many research infrastructures are now working with industry. This is Procter & Gamble. Huge company. You must have heard of them. And if you haven't, you have now. The products on the screen, some of them still exist. The slide's getting a little bit old. If you wash your clothes, if you have a shower, if you have a bath, if you do brush your teeth and stuff like that, somewhere, somehow you are using a Procter & Gamble product. And they came to the ESRF. This is a long time ago. We're allowed to talk about this. And now washing liquids. When I was younger, a long time ago now, we bought washing powder, washing liquid in very large, heavy bottles. Procter & Gamble wanted to make those bottles smaller. And to do that, they had to reduce the volume of the washing liquid, in this case, Ariel. And to do that, they needed to reduce the water content. And in doing so, they wanted still to have shelf life, product stability. The product had to work, had to look sensible, right? So to do that, they came to us and they used small angle X-ray scattering on one of our beam lines, and they basically looked at the phase diagram. Really simple science, actually. Simple stuff for a synchrotron. And they mapped out the phase diagram of their product, and they found areas where they could basically remove water, some of the water from the product, basically compactify it. And now these days, right, you put into your washing machine those little gel packs, poof, in it goes. The basis of that is work at the ESRF, and where that product came out now many years ago, and it's still been adapted since then. And that's generated a market worth billions for Procter & Gamble, which is good. We like that. And it's a nice story that we are allowed to talk about. Again, a lot of the stuff we do with industry is things that we not allowed to talk about because it's confidential by the nature of the work that they're doing. But Procter & Gamble is a very innovation and research-driven company, and this work here helped them to do that development. Very simple experiments for us, routine. Right? Each of those measurements would have taken a couple of minutes on ID2, but it's work that was absolutely required in order to understand and help Procter & Gamble develop their product. What does industry want from a synchrotron? This is Anna Sandstrom, who's from AstraZeneca. This is going back a few years as well now. But you can see this is a slide she put up in a workshop somewhere. And here she's saying, well, they want to maximize impact of these facilities for industry. They want routine measurements. Keep it simple, a fee for a service. It's not research. They want to buy a service. They're also open to R&D collaborations. They want dialogue. They want to understand. They want resources, feasibility studies. They want easy and timely access across infrastructures, effective handling and technical software solutions for samples, data collection, analysis management. They want an A to Z workflow. Keep it easy, keep it cheap, keep it reliable. And they want an agile and cost-efficient setting because they're industry, right? They're not like some kind of gold mine with loads of money. They're ready to spend the money, but they want a service that works for them. Again, adapting the synchrotron to industry, not the other way around. And often when we're going out talking to industry, we kind of get this reaction that we think we've got the answer to all their problems, but because it requires a change in the way that we think or the way that they think, people say, well, we're just too busy. We haven't got time to think about this. It might be a great solution, but we're just not that interested. And breaking through that barrier with industry in marketing to them, having the conversation with them about what a synchrotron can do, a neutron source can do, what a laser source can do, is so important. And we spend, as I said earlier, a lot of our time talking to industry and convincing them of what we can do. Go back to that video I showed earlier on. This is one of our structural biology beamlines. It's highly automated. It has a robot. it provides what industry really needs. And industry's been a very strong driver behind the design of these beamlines and what they do. Each of the samples has a barcode on it. It's uniquely numbered, identified. It's in a database. The data are collected automatically. It's all streamlined with smart software. The robots do the work, and the robots work 24 hours a day. When I was on the beamlines, I dropped samples at 2 o'clock in the morning because I'm tired and I'm not working as well. The robot works. So in this case, industry is getting automated, reliable, rapid, cost-effective, and high-quality and trusted data collection. And now the ESRF, as does every other synchrotron in the world, basically, we process tens of thousands of protein structure samples every year for pharma industry. We're knitted into the drug discovery pipeline. And AstraZeneca recently said at one of the big European meetings that all drug targets for 34 oncology for cancer, new molecular entities approved in the period 2019-23 were characterized using protein structures collected using synchrotron light sources. The data that we produce are early in that drug discovery pipeline, but they're essential to the way that the pharma industry is seeking to develop new medicines and new drugs for the market. And the automation that you can see on the screen is a critical part of that process because it makes it cheap and reliable. This is argon. This is the APS over in Chicago, the Advanced Photon Source, beautiful synchrotron in the US. In the US, they have beamlines that are called the CATS, Collaborative Access Beamlines. And this is one that's run by IMCA. And this is Lisa Key from the beamline that kindly let me use these slides a few years back. And here, this is a beamline dedicated to the pharmaceutical industry. Pharma owns and operates the beamline as a consortium. This is some of the statistics. You can see the numbers of structures being produced annually, the capabilities of it that they have, the industry members, this may be a little bit out of date now, who subscribe into the beamline. But in here, you can see the kind of drugs that have been enabled by the data being collected on those beamlines. And it'd be wonderful to show the same information for the ESRF and European facilities, but actually we can't track back, going back 10 to 15 years with what was collected when, where, by whom, and what impact it had. Fortunately, at IMCA, they can. So here are some drugs where the drug discovery has been directly impacted by structural biology data from a synchrotron. So it's here for things here for breast cancer, antibiotic, leukemia, an AIDS drug, type 2 diabetes, kidney cancer, and one of the more recent ones from Pfizer is Paxlovid, which was involved with COVID-19 and the work in helping to control COVID. Each of those is earning money, right? Each of those, I have no idea what the income to the companies is of those drugs, but each of those drugs is earning significant income as well as the health benefits to the general population. I suspect that any one of those drugs could justify a multi-million euro investment in a synchrotron because of the impact of the synchrotron data has on the drug discovery pipeline. This is another example of working with industry, and this is where we adapted the synchrotron at the ESRF to the needs of BASF. Now, BASF, huge chemistry company in they would say the world's biggest chemistry company based in Germany, down in Ludwigshafen. They came to us and said, we want to collect X-ray powder diffraction data, and we want to collect lots of it because they're using this kind of powder diffraction data in materials discovery for catalysts, for battery materials, agrochemicals, for other things. And using their in-house X-ray source, quite frankly, it was just too slow. It wasn't working, and to collect the data they needed would take literally months, if not years. They said, "Well, we'd like to come and can you help?" We said, "Yeah, we can help out there." At the time, we had some European funding, and using that funding, we designed from scratch the sample holders, the systems you can see on the screen, to do high-speed X-ray powder diffraction. So instead of taking hours for a data collection, this is seconds. That's real time on the screen, and the system collects powder diffraction data with the detector in one position, and then it collects powdered PDF data in the second position. And then this makes it highly cost effective. We can process 1,000 samples an hour or so using this system. And this has actually resulted, Bernd Hendrickson, who came to us from BASF, he actually saw a business opportunity. He's now stepped out of BASF and he's created a company called Momentum Transfer, which now employs 10 people, provides an A to Z service for industry or anybody else who wants to buy the powder diffraction service. They've raised over 1 million euros in venture capital And I think they're going to try and do some more VC raising in 2026. And this system now, we're working in collaboration with DESI, German Synchrotron, over in Hamburg, with funding from BMBF, which is the German Science Ministry. And we're developing the next generation of sample change and sample support, which will be installed both at the ESRF and DESI. So opening up more capacity for this high throughput technique. And this is being enabled by momentum transfer because they also want to have access to two synchrotron facilities. If you're running a business, you can't rely on the fact that one synchrotron is the only place that may be able to collect your routine diffraction data. That would be a big business risk. So momentum transfer is sensibly trying to build this up at both the ESRF and at DESI. So if the ESRF stops, they can go to DESI. If DESI stops, they can go to the ESRF. And they probably would use both synchrotrons. And that's a very nice example of how we've adapted the synchrotron to be applicable to a specific challenge where we were challenged by BASF. Even at the time. We also work with research and technology organizations who, in this case, this is DTI, the Danish Technological Institute in Denmark, who approached us to use computer tomography on tiny fish. And they're working with a company called BioMar. BioMar make fish food. This is not nature front cover stuff, right? But what happens to the fish food that BioMar produce and how the fish digest it, how they absorb it, is something that they're very interested in. And a way to do that is use CT at a synchrotron source, which provides very high contrast in a fish which is made of mostly soft materials together with a skeleton. And using our technique, they could see, excuse me, they could see inside the fish, understand what's going on in the digestive tract, and you can see a lot of details of the fish without staining. No chopping up the fish like in conventional histology. You can immediately see details in there. Now, in this case, the ESRF is responsible for collecting high quality data. DTI are responsible for the translation of that data into something that BioMar could understand. And BioMar are the client of DTI, and DTI were our client. So DTI in this case are acting as a multiplier and a bridge out to their clients, which is important because the ESRF responds to 19 countries, and we need those multipliers out in the real world. This is an example with battery safety, which is also a topic of great interest to industry. This isn't, well, I'm not showing you confidential data here. This is publicly available data, but we do this kind of work confidentially with companies. You can see a standard battery, a jelly roll battery. That's a smart nail puncturing the battery. It's a smart nail because it's measuring the temperature, and you can see that creates a short circuit. This is high-speed X-ray imaging on ID19 at the ESRF, watching the internal content of the battery disintegrate. Basically, and you can see the time over here. This is now coming up to 2.3 seconds, 2.4 seconds. So this is very high-speed radiography, watching how batteries are destroying themselves and trying to make them safer. So NASA come to us commercially. We're allowed to talk about it. And they buy beam time at the ESRF and they test a lot of batteries, as do other companies that use us confidentially, looking at battery safety and looking how they can design batteries to be safer for space uses, but also aerospace. And last year, 2024, actually 2 years ago now, time goes by quickly, Archer Aviation, an American company, signed a deal with NASA on battery development, and they're using the ESRF for this worldwide unique battery testing facility. And we work in turn in using this with the Fraunhofer Institute and UCL over in London to provide, again, an A to Z service for industry. We are great at the ESRF in providing the X-rays, the beamline, but we need the segments around it in terms of the experiment setup and the experiment data interpretation, provide a global service to industry and not just data. And that's an important feature of working with industry, as I keep saying. We can't always make it easier for industry. At the end of the day, the ESRF is an academic facility. We have site access administrative steps. We have safety considerations. We're on a nuclear site with the ILL just next door. We have to sometimes have samples sent across borders, transnational borders. We need to track them. But we do try to keep things as simple as we can. So we have a short quote. We handhold the clients through the access steps because they're not coming to us every day like some of the academics. We work with the non-disclosure agreements, the master service agreements, and material transfer agreements of companies. And again, one of the surveys we did, what is a perceived barrier that can impact the use of the ESRF services? Cost. Okay, we actually provide our services at cost recovery. We don't make a profit. It's part of our mission to work with industry. So, but we have to, according to our financial regulations, we have to provide the services at what it costs us. So it costs us €1,000 to provide the first service. We charge €1,000 to the company. But also one of the limitations was scheduling time. The amount of time it takes to between contacting us and getting the access. And that's really somewhere where we can play in trying to minimize that as much as we can. And so on the beam lines that are popular with industry, we pre-reserve regular slots and they go on a first come, first serve basis, though we're experimenting with some other ways of doing that at the moment, so that we can provide a quick and timely access to companies that need it. One thing we don't do at the moment, but that nonetheless is perhaps on the horizon, is things like ISO 9000, good laboratory practice, or even standard operating procedures. So at the moment, we don't have a formalized quality assurance framework at the ESRF. The Australian Synchrotron is ISO 9000 certified for the whole facility. At the ESRF, we haven't done that yet, but we're getting noises from some clients that saying, well, it would be, that's the kind of thing that we might need to do to be really embedded into the industrial commercial world, because this is the kind of thing that they seek in industry. You have an ISO 9001 compliance. You follow a rigorous procedure, and it's the same every time. That's not just the data collection on the beam lines, but it's also how you produce the quote, how safety works. That's all ISO 9000 stuff. And for some companies, that may become an issue in their future use of facilities because they will need to have that depending on the type of work they have. If in the technology readiness level you're down at 1, 2, 3, basic science, not a big deal. If you're up at 8 or 9, close to market, then or doing legal work or doing patents, then maybe ISO 9000 or GLP becomes an issue and something that needs to be done. Barriers can be money. Now, we can't change the cost of the ESRF. We can make it faster, which makes it cheaper. But for small, medium-sized enterprises, SMEs, actually having access to places like the ESRF can be limited by cost. Now, in Europe, the European Commission is allowed to subsidize SMEs, whilst the SMEs, if they access us using subsidy, can still have confidential access. So the data is still kept secret. So now under 3 projects, we've had something like 60 or 70 SMEs accessing facilities across Europe with SMEs. And this is an important part of any economy in the world. The small, medium enterprises are the nimble ones that are developing the innovation that eventually finds its way into larger companies, or the SME builds into a large company. So supporting them is an important part of our economic impact and something that we must do. And helping them with subsidy and even more hand-holding them for the big companies is really important. And we've been experimenting with that. We hope to carry on with this in the future with further funding. These are 3 examples. Now, going back a few years, I have to admit, Takis Biotech is a little Italian company. They came to us with tiny samples seeking to get structural biology data linked to COVID therapy. So we help them collect the data and solve structures, support them through the whole process. Scandiflash, Swedish company, looking at instrumentation with radiography. They came to us looking to do work on ID19 as a comparative. And Hey Planet, Danish, they came to us with non-meat food ingredients. They wanted to look at the 3-dimensional structure because that has an important impact on the texture, how the meat replacement feels when you're eating it. Because that's a clearly important part of if you're developing these ingredients, these products, it has to be something that we actually want to and like to eat, otherwise the product's going to fail. And all of the experiments there were actually relatively simple, straightforward for us. Structural biology, a little bit of instrumentation comparison, some micro CT. But for the SMEs, it helped out enormously to understand what's going on with their products. And the access was subsidized and supported through the European Commission. I won't do with that. I haven't got time. Don't worry about that. We also work with industry through further European funding, and we try and provide innovative ways for access. This is a project called Remade at ARI. It's still running. This provides access to a wide range of European research infrastructures from anybody in the world, access to neutron labs, lasers, synchrotrons, electron beams, particle beams, all sorts of stuff in the mix there. You can go and look if you want to. Then here we trialed different access methods for industry. This is just one example where we provided up to €30,000 for an intermediary company, and I'll say more about those in a second, to support Siemens Energy in using the ESRF. So if Siemens Energy are interested to look at additive manufacturing, and how the objects that they additive manufacture, how perfect they are, how well they're made. They're looking for defects. Now, this is a heat exchanger, and using synchrotron tomography at the ESRF, Exploration, which is a tiny company over in Berlin in Germany, collected the data for Siemens, did the analysis of the data, did the sectioning of the tomography data to look inside in very, very fine detail. And now you can start seeing some of the coarseness of the additive manufactured object. And this is providing an insight for Siemens Energy in the quality of their additive manufacturing. Where is it going wrong? Are there defects in there? Is it okay? And this is for a heat exchanger. So the fluid channels need to be very smooth. They need to be open, all this kind of stuff. So they're trying to understand that. And this was supported by European Commission funding with Exploration, the ESRF acting as the data provider, Exploration acting as the knowledge provider, translating the data into knowledge for Siemens. And Siemens was the problem holder, is the challenge in trying to understand and looking at the detailed structure of their heat exchangers. And this is some beautiful X-ray computed tomography done by Exploration on beamline BM18 at the ESRF. We also are fortunate to be a partner with the European Innovation Council. This is an entity in Europe which supports innovative research and development. And ESRF is a partner in their ecosystem, which means that companies that benefit from EIC funding can automatically, if you like, use the ESRF for access. We provide free consulting, and there's some specific services for beneficiaries from the EIC. So you're starting to see a picture of how we try to engage with industry with multipliers, going to innovation councils, going at a country level with BASF, all sorts of different ways to engage with industry there, because we have to have those different multipliers, with the EIC being one of them. I won't go into details there. This is Max 4, Swedish synchrotron, the Swedish synchrotron, national synchrotron up in Lund. Max 4 are based in Sweden. Sweden has a huge quantity of trees, loads and lots of trees. And a lot of industry in Sweden is based around the use of those trees, whether it's IKEA. If you haven't got an IKEA product in your house or home, no matter where I go in the world, you travel from the airport to the town centre, there's a flipping IKEA store somewhere standing out in yellow and blue, anywhere in the world, pretty much, I think. Tetra Pak, if you've got those fruit juice milk cartons, Tetra Pak is in the mix there. These all use wood or cellulose products. Max 4 responding to this interest from their industry base in Sweden by building a beamline called 4Max, which can look at the different hierarchical scales of wood. It goes from growth rings, cellular structure, all the way down to the atomistic molecular cellulose level. And understanding the structure of wood is important to its end use, how it's transformed, how it's used in industry. And in this case, Max 4 got funding, a large amount from the Wallenberg Foundation, which is a big charity in Sweden, but engaging with the Swedish forest industries. And their goal is to contribute to the competitiveness of the Swedish forestry companies, focusing in the paper pulp industries, Tetra Pak and others. This beamline is now active, and they're doing beautiful science over there, looking at paper, wood, amongst a wide range of other things, right? But this is a wonderful beamline over there with a direct link to the Swedish industry, so driven by national interest in Sweden. Big problem with industry, as I hinted at earlier on, is industry don't understand us. Synchrotron, what's that? ESRF, don't know what that is. X-ray powder diffraction, what on earth is that? X-ray Raman, haven't got a clue. So actually the outreach, the translation, the matching between the synchrotrons, the research of instructed industry, and reaching a common understanding, a common language is so important. We spend a lot of time doing that. You know, we've got clients and we get those because of the outreach, the visibility, and matching what we do to industry needs. But as I've hinted and you've seen building, we have an innovation system around us. We work with things like the EIC, funding agencies, technology hubs and partnerships. Innovate UK is another example. BMBF, Fraunhofer in France, France 2030. This is the Advanced Materials Initiative, which is a European-wide initiative on advanced materials with a lot of industrial drive. So we can use these as multipliers to reach out to industry on that scale. On another scale, the RTOs, CA in France, DTI that I mentioned earlier on in Denmark, Fraunhofer in Germany, VTT in Finland, CDTI in Spain. All of these also are known at a national level. If I go out in Germany and say, we're the ESRF, would you like to use us? They're going, who the hell are you? Go out with the Fraunhofer. The Fraunhofer is a household name in Germany. So using them as multipliers and bridges at the national scale is really important to us, and we're seeing much more of that happening now. But most of all, it's really exciting to see over the last years uh, quite a wide range of specialist science companies building up the bridge between our RI world and the commercial world. For example, Novatom in Grenoble focuses on tomography, other techniques as well, but the focus is tomography. They design experiments, they market, they translate the data that they collect at the ESRF into results that are usable by industry. Finden, spectroscopy, largely in the UK. Exploration, tomography over in Germany. Insidics, tomography again in Grenoble, but for large, typically electronics or manufactured objects. Expose is structural biology based in Switzerland. Rubis in Grenoble as well. CT, momentum transfer, X-ray light diffraction, I mentioned them earlier on. And AXAM, a wide range of techniques based in Switzerland as well. These are all incredibly valuable companies to us spread across Europe, if not around the world, and who know what a synchrotron is, can speak industry, and can provide an A to Z service. And some of these companies here are now some of our biggest clients. We don't know who their clients are, but they use us by beam time, add value, and are doing the full A to Z service. Very, very important to us. And that whole innovation ecosystem is growing rapidly and is part of our strategic part of the future plans of the ESRF and how we engage and build this system here. We do a bit of, I'm nearly finished. We do a little bit of technology transfer. We're lucky at the ESRF. We develop a lot of our own in-house technologies, be they mirrors, slits, shuts, oh dear, sorry, detectors, slits, shutters, mirror systems, crystal analyzers, scintillators. We make these available by selling them or doing tech transfer. Um, we can discuss for hours patents, which are definitely not a favorite tool of mine. Very heavy, very expensive, very cumbersome. So a lot of time we keep secret what we're doing rather than trying to patent it. It's an example of sort of a tech transfer. This is Ceftech down near Toulouse. They provide services linked to magnets, and we've sold them one of our magnetic measurement test benches, which you can see on the right hand side here. This is from LinkedIn a little while ago now. This thing costs quite a lot of money, right? This costs a very nice Porsche car, or you can have a magnetic measurement bench. I know where my money's going. They bought it to add that service of magnet testing. So you can measure very precisely the magnetic fields from here. These look like quadrupoles to me. And our test bench allows them to measure that themselves. Before they were buying that in as a service from somewhere else. Now this is added to their service offering and they're making money from it. They bought the tent bench from us. We've taught them how to use it, and they trust us in enough that they borrowed money and got a grant to actually buy that system from us. And that's adding value to a nice French company who are a valuable company in their own right. Alba, Spanish synchrotron. These guys have their own magnet measurement laboratory. And this is a key feature in the ecosystem of Barcelona, if not wider afield in Spain. And Alejandro Sanchez and the team down there provide access to the magnetic measurement bench with the special facilities to clients and companies that want to do the magnetic measurement benches but can't afford to buy the benches themselves. So they come in, they use the lab, they benefit from the expertise of the Alba engineers. So this is not an X-ray beam line. This is an ancillary laboratory at the synchrotron that industry are benefiting from, because it's at a synchrotron, it's not just about the beam lines. We've got specialist laboratories around the beam lines also that the companies can access if they want to. This project's finished, but I think it's worth mentioning. It's in over-XN. It's funded with European Marie Curie funding. We had 38 PhD students, and each of those students had an industry who was driving the research challenge and was a co-supervisor. So here the students concerned got involved with industry. Their research using synchrotron X-rays at the ESRF or neutrons at the ILL was driven by that industrial demand. They were doing research on catalysts, materials, drugs, all sorts of products in there. And they got experience of commercial world and research infrastructure world and academics. And the topics being studied were extremely broad. Pharma, biotech, catalysis chemistry, energy production storage, think batteries, but also construction materials, agriculture, aerospace, consumer products, think Procter & Gamble, all in the mix there with getting a lot of wide experience in different areas. I think what I'm going to do is going to skip that because I'm going to run out of time. This is the last slide, basically. This is Jake. Jake, who's our youngest son, is now a lot bigger and older than that. But I like this photograph because for me it emphasizes we don't know everything about how to engage with industry. We're maturing and growing up and learning every day in what we do with industry. Every time we're doing something different, we're developing a new service, we're engaging with industry in a different way. And every day we're learning. And we do very much like working with industry as part of the mission and the heart of the ESRF now. But stakeholder and European support is critical. The engagement of the facility directors and the staff is absolutely key as well. And no matter what we do, outreach, and visibility of the ESRF and the facilities to industry is absolutely critical. And we do that on a daily basis in many, many different ways. I don't do this on my own. I'm just lucky to have an absolutely gorgeous team to work with. This is a slightly old photograph. We have a core team. We have people on the beamlines. We have people in contracts and legal that help us. But the whole ESRF is engaged in this work with industry. And with that, thank you for your attention.
Thank you, Edward.
You're welcome.
Informative and interesting talk. Now we can open a Q&A session. Please, if you have any questions, you can write them in the chat, or if you prefer, you can raise your hand and we'll try to unmute you.
Okay.
Sonia, maybe you would like to ask a question. Can I unmute you? It's an interesting thing, but maybe you can explain better.
Hello again. Thank you, Natasha.
Thank you.
Hi, Ed.
Hello, Sonia.
So you know that I work in heavy ions, right?
Yes. Yeah.
And we were never conceived as a user facility. We just sit here in the wood doing our fundamental research. But much like ESRF, we've also come to understand that to do excellent science, we really need to engage industry and want to engage industry and do engage industry. But we will never be able to catch up with what you've been doing.
Don't underrate yourselves.
Well, I put in the chat, we're 54 years old. We had our very first industry beamline last year.
Oh, right. Industry beamline or industry use? Industry beamline.
Industry use, sorry. Industry use.
Industry use. Oh, right. Okay.
Not beamline.
Yeah, okay.
Industry use. And this year, we also have 48 hours earmarked for industry. 48 hours of the whole year.
2 days. For
industry use. So this is where we are. Now, my question to you is, I've written down everything you said, and I can't do it all. So where should I start? What is easy for us to do to make these 48 hours really pack a punch?
Bloody hell. Well, 48 hours means potentially a 12-month wait for industry, which is just impossible anyway, I think. My first step would be to question the facility strategy. Do they actually want to engage with industry, or is it just kind of not really that motivated? Do the directors and the stakeholders want you to work with industry? Because 48 hours off of one beamline in probably what is a multi-beamline facility is very limited, right? So my first step would be to understand what the facility strategy is in working with industry. A, do you want to? B, how are you going to go about doing it? C, what resources are you going to put in place to enable it? Because without that, it feels like you're not really sort of moving forwards very quickly. In terms of analyzing your 48 hours, I would go out and identify, I don't know how much time an experiment takes at your place, but maybe that's 1 or 2 clients. I would go out and phone up, get in touch with 1, 2, 3, 4 companies and persuade them, because you can do that on a one-to-one basis. You don't need to be machine gunning kind of widely. You've probably got services there that could respond to the needs of a couple of key clients. And by the time you've done that, you've burnt your 48 hours. So I would do 2 things. 1, shape the facility response to industry. What do you actually want to do as a facility strategy and policy? And 2, I would contact specific companies for your 48 hours, because you've got a very limited resource. And you must know which companies want it, probably. Do you? Sonia's gone.
Yes, it seems so. She's thanking for the answer.
Okay. I was watching the chat.
Yeah. Next question from Adrian. Would you like to unmute, Adrian? Or I can read the question. So he's asking, what are the drivers for trying to grow industry beam time 5% a year, given you only ask them to cover the costs, not for profit? Does it not just lock more data behind confidentiality agreements?
Ah,
Is it an admission that government investment is not keeping up with the costs of running the facility?
an open data fan, I hear. I can sense, right? I the driver is because our member states want to see a faster and greater economic return from what we're doing and how we're able to help competitiveness of the member state companies. So there's a drive for that. It's a mixture of everything in there, Adrian. One, competitiveness, we can support companies. It's part of our mission, especially in the world we're living today. Two, we do need the money. Budgets are very tight and very condensed at the moment, and all the additional money we can get from being entrepreneurial with industry is valuable. At the moment, just to give you an example, at the moment, the investment budget of the ESRF is about 20 million euros a year. That's our money that's not pre-committed into electricity, staff, user programs, stuff like that. It's the free money that we can invest where we see fit. So suddenly 4.5 million euros of income out of 20 million euros of investable cash makes the industrial income extremely valuable. It gives us a little bit more flexibility in what we're doing. And three, it generates the stories. Generates the stories that helps to keep the government subsidies coming in, that we can carry on doing the fundamental TRL 1 to 3 science, which is the open data, which by far and away remains the majority of the work we're doing at the ESRF. Last year, we were at about exceptionally 8% of beam time for industry. So that's still 92% of our beam time for open science, whomever is using it, whether it's industry or academia. But I think there's a very big drive certainly amongst European research infrastructures to demonstrate our relevance for the now in terms of the societal challenges that we face for energy, pollution, sovereignty, and many, many other topics. There's a very big push from our member states for that. And the 5% growth per year is one reflection of that expectation.
Thank you. There was a few comments by Marcus Kirk. If you would like to raise them yourself, Marcus, let me know. If not, I'll read them. EUV lithography with a FEL is being worked on at XLightCom. And the second, nuclear reactions with synchrotron radiation is being done in China, ESRF. Efforts for such a facility in Europe exist, as he read somewhere, but he doesn't know the status. Maybe you can update
the EUV litho stuff, if that's happening somewhere, because it's EUV, so it's outside of the ESRF spectral range where we're hard X-rays.
Right.
That'll be over at Flash or XFEL, or depending on the energy, there's the baby FELs, which is not the right word, over in in Denmark at Aarhus. There's Felix, and there's a couple of other places as well. But I'm not familiar enough with that work, but certainly there for the litho FEL work, there's also a direct relevance to semiconductor sovereignty with the lithography for electronics. The nuclear radiation, I'm not sure what that refers to be honest. You can use very, very, very intense X-rays to generate radioisotopes for medical purposes, but the amount that you can generate is teeny, teeny, tiny compared to, say, the ILL just next to us with a very nice neutron source.
Thanks. Zahid is asking, the slide lists advantages like higher spatial resolution and faster data collection. For an industrial user concerned with cost and time, which single advantage is usually the decisive factor in choosing a synchrotron over a lab source?
Oh, bloody hell, that's a good one. It depends, because it could be, there's two things there. One, maybe the synchrotron is providing unique data, in which case they have no choice. They've got to go to the synchrotron or the neutron source, wherever they've got to go to get the data, because they need it so much, they will go there. And we've got examples of that again, which I can't talk about. The other one is because we can go fast, and it gives them a cost benefit in terms of the numbers of samples that they can scan that they simply can't do at home. Last year in one run, one experiment, we scanned 1,000 batteries. You can't do that with a home source, not at the resolution, the quality of the data we can provide, and at a cost. The cost per battery was tiny, right? 50 euros per battery or something, because you could scan batches in one tomogram a batch of 10, a batch of 10, a batch of 10. And that's a real driver for industry in terms of coming to use us. I think the overall drivers, in some cases, cost is secondary because they want the data. And there's an interesting question that somebody might ask about why don't you put your prices up? Why is it cost recovery? We can debate that as well. There's a cost, there's a price, sorry, there's the uniqueness of the data that they can't go and get anywhere else. And that'll be the driver to come to us. In the end, it's the quality of the data and the uniqueness. In some cases, it starts to also be cost. I didn't talk about AstraZeneca, who have thrown away their in-house X-ray source and now rely on synchrotrons to collect their diffraction data of structural biology, not just the ESRF, but other synchrotrons as well. That shows the trust in us, the quality of the data, and also the economic fraction, the economic equation of using a synchrotron for that part of what they want to do. Because if it was too expensive, they wouldn't do it. And that's also an interesting thing. People say, well, what's the value for industry coming to use a place like the ESRF? I would dare to point to the €4.5 million a year that we're generating, and they wouldn't be coming back and time again to use us if it were not valuable for them. The challenge is we can't talk about the stories because it's confidential. But I would point to the number and say, well, that shows some of the value because they do keep coming back and they spend the money. Sorry, that was a very long-winded answer.
Interesting, though. Yeah, it seems that we finished all the questions.
That's great because just into my next meeting.
Thank you. And since we are a little bit late for the break, I would suggest that we just keep going with the next talk, which is cultural heritage applications